Okay, in this video I want to cover a few points. Mainly I want to show how a Dmux mainboard from the Cirklon Dmux module can be used as an internal retrofit for an old drum machine. And I want to also just show why that does a better job of triggering a drum machine than using a Midi to trigger device. Okay, so I've got an 808 here. I've set this up just to demonstrate how great the timing is in these old drum machines, because internally what's happening with these drum machines, the actual timing behavior response to incoming clock is not as stable as you might think. There's a fair bit of jitter, but when these drum machines trigger their sounds on a given step, every sound is triggered exactly the same instant. There's no variation in the timing of the trigger pulses. So I want to show that by having a pattern, the 808. So far I've put in a bass drum. I've got a snare drum here. I've turned the snappy down, so it just is going to add another tom type noise. And then I'm going to add the low tom, mid tom, and high tom. And we'll put in the rim shot as well. So that's bass, snare, 3 toms and the rim shot. That's 6 instruments all triggering at the same time. You can hear, if you listen to those, every trigger is consistent. There's no variation. The sound, the combination of those sounds triggering on each step sounds the same every single time. So what I'm going to do now is just flip this machine over, open it up and attach a Midi to trigger interface so that we can look at the difference between triggering internally and triggering from Midi triggers. Okay, so now we've got the 808 opened up. This is an old Midi to trigger unit I designed many years ago. Basically what it does is it takes MIDI notes in. Whenever it sees a MIDI note that's mapped to one of its trigger outputs, it generates a 1 millisecond trigger pulse on that output, with the voltage varies according to the velocity of the note. So I can reach the start stop button. Here's the pattern I did. So this is the internal sequencer on the 808, and it's triggering those 6 sounds on every step. Now I've got that same pattern set up on a sequencer. So that's the MIDI input now driving this. But if you listen to that pattern playing, you can hear that it doesn't sound the same on every step. The sounds seem to change a little bit. Now the reason for that becomes really obvious if we look at what's happening on these triggers with oscilloscope. Just happen to have one here. Now I say at this point that the modification to allow trigger inputs to these drums has been done by replacing one of the transistors in the circuit that generates the trigger pulse for each instrument with a little board here that allows an external trigger to be safely mixed in with the original trigger pulse. So at the same time we can both trigger this machine with its internal sequencer. That's me running the external sequencer. So the internals, they're not synchronized. One pattern's the internal, one pattern's the external. They can both run at the same time. So I'm going to hook my scope probes up. Okay, I don't know if we can see. I'll just pan around with though and zoom in on the scope. Okay, so this is the internal sequencer triggering these sounds. If we look at the pulses, these are the trigger pulses. They vary slightly for each sound just because of the way the circuit uses the pulse. We're looking at the pulse at the input stage of the circuit. But you can see, if we stop this, these pulses are all completely aligned. They all happen at exactly the same instant. if I run the external sequencer, what you can see is the pulses are spread out in time. Stop and look at this. You can see in this time base we're looking at 1 millisecond per interval. So you can see there's 2 milliseconds delay between the first note pulse and the second one. They're separated by at least half a millisecond between each pulse, thereabouts. The reason for that is MIDI is a serial protocol. MIDI note-ons take 1 millisecond roughly to send, unless there's running status involved. Running status makes it slightly quicker, only takes 2/3 of a millisecond to send. But basically, if you're trying to send 4 triggers at the same time, it's going to take you at least 3 milliseconds for those triggers to go out, and they're not going to happen all at the same time. That's the reason why the internal sequencer, every trigger sounds exactly the same. But running with MIDI, the sounds vary on each step, because depending on the order that those notes are sent by the MIDI sequencer, each of the different sounds might start in a different time, very slightly different time, but that's enough for the sounds to interact with the oscillator waves. You know, they'll interact with each other differently depending on the very precise timing of when those things start. The scope here is being synced just to the yellow trace, which is the bass drum trigger, and then the other triggers you see, just because of the limitations of MIDI, jump around that time. The more notes you're trying to hit at the same time, the more obvious it becomes. But if you were trying to trigger all 11 sounds in the 808 at the same time, that's going to take you 8+ milliseconds. So there's a big spread of when those triggers happen. If you're doing it internally, they all happen exactly the same instant. So what I'm going to do now is take this old MIDI trigger unit out, attach a drum mux as an internal retrofit, and show you how the timing of that compares to the MIDI triggering. Okay, so now we've got the MIDI to trigger interface replaced with the drum mux interface. This board here is the main board from a drum mux module. The drum mux module itself is just a little desktop box, or we also do them in a Euro rack form. This board is just the main board from inside there without the jacks, and it's able to take ribbon cables so that the trigger outputs can be wired directly, just in the same way as the MIDI to trigger interface was connected. This is the I/O board for the drum mux, but when it's used as a retrofit, normally the ribbon cable here would wire directly to a DIN socket somewhere on the chassis. This 808 already has a couple of DIN sockets fitted because it has its MIDI interface. When I finally install this, I'm just going to wire that directly onto the DIN socket, but just for the purposes of the demo I've got it plugged in here. So the 808 still has this pattern, triggering those 6 sounds at the same time, and again we're hooked into the scope here. We look on the scope, again we can see it's totally consistent triggering time. So if I stop the 808 and I have the same pattern set up on the Cirklon, this time sending using the Dmux interface, you might notice a very slight change in the leading edge of the signals just because of slight differences between the circuitry. So I'm stopping the Cirklon. These are the pulses from the 808's internal sequencer. You listen to the tones, it's got that consistent sound. Every trigger sounds exactly the same because the sounds aren't triggering at slightly different times relative to each other. I'm back with the Cirklon playing it. So the Dmux has the same synchronised triggering of all the sounds that are supposed to happen at the same time, just exactly the same way as the internal sequencer would give you, and gets rid of that MIDI flam. Okay, so this is the drum mux module in its final installation, screwed onto the base of the metalwork with enough clearance so that there's no problem with the circuitry that comes down and sits over the top. The wires are on ribbon cables, so these just need enough length to fit into the board when we bring the top piece back over. So this is the normal 11 triggers, plus I've added in a little extra one here through a diode to trigger the maraca. The clap and the maraca are on a switch on the front panel, the 808, but they are two separate sound circuits, and the switch is just there because the limitations of the processor. So the maraca is available as a separate sound to the clap. It can be triggered at the same time or independently. So basically this just needs to come down far enough I can reach the ribbon cables, plug them into the main board and close the lid. Put the screws in and it's ready to go.